All right, so today we're going to talk about atoms, elements, and compounds. So before we begin to learn types of chemical reactions, we must know the difference between atoms, elements, and compounds. So we're going to start off with the difference between an atom and an element, okay? So one atom, we're using a Rutherford model here. So we have 3 electrons swirling around a nucleus. We know that's not the most current model of the atom, but it's really easy to visualize here. Just one of those is an atom. But if I took 6.02 times 10 to the 23rd atoms and piled them together, and we weighed them on a scale, it would weigh 6.94 grams per mole. We calculate atoms in a mole, kind of like 12 eggs make a dozen. So atoms are so small, we pile them really close together and we get enough of them to make 1 mole. So if I take exactly 6.02 times 10 to the 23rd atoms of any element and I look on its periodic table, the mass at the bottom is actually telling you what it would weigh for 1 mole, or 6.02 times 10 to the 23rd atoms of that element. So elements are essentially a collection of atoms, all the same thing. So I want to talk about atoms, elements, and compounds. Look at H2O and N2O3. Try to analyze how many elements, atoms, and compounds we have in just H2O. Pause the video, play for the answer. Notice in H2O we have 2 hydrogen atoms and 1 oxygen atom that give us 3 total atoms in that compound. We can also call it a molecule since it is covalently bonded. Same pattern here for N2O3. We have 2 nitrogen atoms, 3 oxygen atoms. That gives us 5 total atoms that make up 1 compound of N2O3. We could also call that a molecule because it is also covalently bonded. There are several ways that you can view an element. And an element is only one type of atom. So in example 1, you'll see that we have the chemical symbol. We've wrote O2, O2. Even though there's 2 of them, they're both oxygen. And so when you look at the model beside of it, you're going to see 2 of the same types of atoms stuck together. And that's totally fine. In example 2, it's only 1 element, and it's also modeled on the right. Compounds and molecules are 2 different types of atoms stuck together. Now these are chemically bonded as well, so when you look at these models, you'll see that they're connected, okay? So in example 1, for a compound, you're gonna see hydrogen and oxygen, and they're stuck together. Granted, there are 2 hydrogens for every oxygen, and in the model, you'll see that it's a white atom and a red atom, white atoms being the hydrogens, okay? And in example 2, you have 4 oxygens and 1 aluminum. And if you look on the right, you can see that modeled. The difference between compounds and molecules is whether they're ionic or covalently bonded. We only use the term molecules to describe covalently bonded atoms. Notice how many different ways we can draw and model atoms and molecules. We can use a chemical formula, a structural formula, a ball and stick model, or a space filling model. Now let's talk about some models of our own. So if I were to diagram or create a model of an element, it would be really easy for just one single colored dot. And an element might be more than 1 dot, but it would be the same color because they are the same atom connected, okay? And a compound would have 2 different colors at least because you have at least 2 different elements or atoms. Notice here I assigned them chemical symbols so you could visualize what that might look like a little better. Now to help us decide if we have an element or a compound, I like to use my circle method. So we're going to put a circle around every element. So I've already done the first 2 for carbon and hydrogen. Even though hydrogen has a subscript of 2, it is diatomic, we're only going to put 1 circle because I'm only seeing 1 capital letter here. This method is going to help you visualize what type of chemical reaction we have so that we can look at which elements we're going to switch when predicting products. Notice how I use 2 different colors to help me differentiate. Notice how when I have a polyatomic, I circle it as if it is 1 atom. You'll see that in the 3 capital letters and the 4 capital letters. When you have only one color, you have an element. When you have 2 circles or 2 colors, you have a compound. This is going to help us decide what type of reaction we have. Another thing to note is if a plus sign is present and which side of the reaction arrow will be on. Now I want you to practice. I want you to circle every element, step back, and imagine whether you have an element or a compound. Pause this video now, then hit play once you've tried yourself to check your answers. Pause this video now, circle your answers, discuss with a partner. Play for the correct answers to be displayed on the screen. Now, look at what you've circled. We're going to discuss whether we have elements or compounds for each one. So in the center, you'll see that I've modeled how I would circle each element so I could visualize whether it's a compound or an element. I've labeled that on the right. Also on the left, based on what I circled, I drew models for myself so I could visualize what I was looking at. Once you learn how to circle each of these elements, you're able to visualize the model in your head, and you're able to understand the difference between a compound and an element. You'll be set up to understand what type of chemical reaction we'll have based on being able to circle, identify elements and compounds, and visualize models for yourself so that we can predict those products.